Hello everyone. So today we will see the frequency response of op amp. So it's an important topic, and many times interviewer also ask questions from this topic. Okay, so for both of the op amp, both ideal and non-ideal, we will see the response. Okay, so first we will see for the ideal one. So for ideal one, we always say the bandwidth of ideal op amp is infinity. First, let me tell what is a frequency response. So frequency response is basically the body plot. So it's gain in dB versus frequency on log scale. Okay, so that's what we call frequency response. So this is frequency response. Frequency response is gain versus frequency on log scale. So the plot of gain versus frequency. Okay, so for ideal op amp, what we say, like this is our op amp, this is positive, negative, this is V positive, V negative, and this is V output. So for ideal op amp, we write V output equals to gain A. Let us assume it is having a gain A, and V positive minus V out, V negative. We can call it VID, difference voltage, A into VID. So basically your gain here is A. So that's a constant quantity. So your gain versus frequency plot would be simply a constant value. It's independent of frequency, right? So it would be a constant value. So that value will be 20 log tan A. So that's your frequency response for ideal op amp. So for ideal op amp, it acts like a whole pass filter, but no op amp is ideal. So in actual, for practical op amp, the frequency response is same as low pass filter. Why? Let's see. So first we will draw the internal structure of a practical op amp. So it is something like this, right? This is I in, sorry, R in. What I can write? I can write VID here, right? Difference voltage. Now this difference voltage would be amplified. This I shouldn't make. I should make it like this by some open loop gain. Difference voltage is amplified with some open loop gain, and now here we have our output. So this is basically our op amp. Okay, like this is amplified, and here I have some output voltage, and this is my V output. Now your op amp is made of some what we say, some FETs, some BJT or some field effect transistors. So all these BJT and transistors are having some junction capacitance and transition capacitance. So there are junction capacitance and transition capacitance. Okay. So now because of that, because of these two capacitance, we can assume one capacitance as output, that we call compensation capacitance. We call compensation, whatever the spelling it is, compensation capacitance. So because of that, we can assume one capacitance at output of the op amp. Like generally we don't make it, but in practical op amp we can have one capacitance at the output. So that we call compensation capacitance. Okay. So this is your V output, and here you have some compensation capacitance where from where this capacitance came, from this junction capacitance and transition capacitance. Okay. So I will simply write it C. Okay. Now you need to write the V output expression. So your V output would be simply in transfer function I will write V naught S would be 1 upon 1 plus R naught CS into open loop gain VID, right, into S, right? Simply 1 upon 1 plus RCS into V in. This V in voltage is AOL into VIDS. Okay, so your gain would be AOL upon 1 plus R naught CS. So now what is this expression? This is low pass filter, right? Let me write it again. V naught S upon VIDS equals to gain equals to open loop gain upon 1 plus J omega upon omega L, that I can write, right? Where my omega L is 1 upon R naught C, right? S simply replaced by J omega, and omega L is replaced by R naught C. So this is my final expression, and this is the transfer function of, now this is low pass filter, right? This is low pass filter. So how you can draw the frequency response? this is gain in dB, this is omega. Okay, so this would be something like this. If you are drawing the frequency response, just draw it something like this. So at 3 dB lesser, so this is AOL gain, 20 log 10 AOL, right? And this is 3 dB. Like, this is not the body plot, this is the exact response. Okay, in body plot we will draw something like this, that you know, right? So at 3 dB lesser, you are having omega L, that is 1 upon that is 1 upon R naught C. Okay, so that's how the response would look like. So basically, for ideal op amp we have this response, but for practical op amp the response is same as low pass filter. Okay, so the response would look something like this. The you can write the gain in this form: open loop gain upon 1 upon j 1 plus j omega upon omega L, and this is how the response would look like. Okay, so now after this video I will deal one question, so from that it will be clear, like completely clear, so you can solve any kind of question after that question. Okay, so I will deal one gate question only, so from that the concept will be clear. Okay, thank you. Hello everyone. So in continuation with the previous video, we have a question on frequency response of op amp. So here the open loop gain is given, the open loop voltage gain is given, and open loop cutoff frequency is also given. Now you have to find the voltage gain at 15 kilohertz frequency in this closed loop configuration. Okay, so the information is given for open loop. First we have open loop. The information is given: gain is 10 to the power 5 volt per volt, and cutoff frequency FC is 8 hertz. And this cutoff frequency we can call it bandwidth as well. Like in low pass filter I have told you the cutoff frequency is bandwidth only, while in high pass filter the cutoff frequency is FC but the bandwidth is infinity. Okay, so that we can call bandwidth as well, right? Now for closed loop, what you can say here, you have what you can say, you in closed loop what is your gain? It is 1 plus R2 by R1, right? It is simply the non-inverting amplifier, so it is 1 plus R2 by R1, that is 1 plus 7980 volt per volt. Okay, now you have to find the bandwidth that you don't have, right? So now you have to find the bandwidth, but you know one thing, in all these circuits your gain bandwidth product is constant. Your gain bandwidth product is constant. I hope you know that, right? So previously what was your gain bandwidth product is what 10 to the power 5 into 8 equals to, now your gain is 80 into new bandwidth or cutoff frequency, whatever you can say. So that would be equals to, your new bandwidth would be equals to, so from here you can see it is 10 kilohertz. So basically, first in open loop configuration and in closed loop configuration. So in open loop configuration, this was your response, and this was, I guess, 8 kilohertz, 8 hertz, and the gain was 20 log 10, like that's of no use, but still I am writing. So it was 100 dB, and here the gain is some value. Okay, so the gain was 100 dB here, and this was 8 hertz. This F and this is gain in dB. Now in closed loop, what has happened is, like, this has reduced, the gain has reduced, because it would be 20 log 10 80, it would be very less than 100 dB, but your this bandwidth has increased. So now this is the same. Okay, now this is 10 kilohertz here, right? So here you have gain 80, like in dB you can write 20 log 10 80. So this is the gain in dB that you can write, and this is the frequency. Okay, so, and at 3 dB lesser, this is 10 kilohertz, because that's what we call bandwidth or cutoff frequency, right? At 3 dB lesser, that the gain that we have at zero frequency and the gain that we have and that 3 dB lesser gain at that frequency, the difference between those two frequencies is the 3 dB bandwidth, right? So now you have to find the gain at 15 kilohertz, right? So that would be here, like somewhere here, right? Here you can find the gain, so that you need to find. Now I have told you for low pass filter what is the gain, like how do you write the gain. So for low pass filter in previous video only, like I must be having this here, yeah. So in previous video only I told you like that's how we write the gain, right? So your gain would be open loop gain upon 1 plus j omega upon omega c or omega L, whatever you can write. This is your cutoff frequency, right? You can write it in f or fc, f or omega, in both of the manner you can write it. So I will write it in f manner, f by fc, that you can write. Okay. So now your gain at zero frequency. So what is this AOL? Like here it won't be the open loop gain. Here it won't be 100 dB or 10 to the power 5. We are talking about this configuration now. Okay. So the gain at zero frequency, if you put f equals to 0, it would be equals to AOL only. So gain at zero frequency, that is 80, right? So your gain at zero frequency, then 1 upon 1 plus gain at what frequency? 15 kilohertz, that you need to calculate, and FC is your 10. Look, at f equals to fc, what you will have at f equal to fc, you will have AOL by root 2. Here I shouldn't write AOL, I should write like A naught. Okay, so at f equals to fc, you will have A naught by root 2, means 3 dB lesser than the higher gain. So that's what we want, na? At fc we want 3 dB lesser than the 3 dB lesser gain than the highest gain, right? And at f equals to f, like f equals to 15, this gain we will have, right? So simply this is what we needed to calculate. So if they ask to calculate on f equals to 8 kilohertz, let us assume, then we would put, we would simply put j omega 8 by 10, right? Now they are asking at this frequency, so that we are putting. So now it would be 80 upon 1 plus j 1.5. So it would be 80 upon root uh, square 2.25 and plus 1, so it would be 3.25. So now let me calculate the answer. So it's 44 point, so gain at 15 kilohertz is 44.37 volt per volt. So that is the gain. Okay, so now I will quickly go through the complete process. So first here we saw the frequency response of practical op amp. तो ये लो पास फिल्टर की तरह था, यहाँ पे कट ऑफ फ्रीक्वेंसी इसकी 1 अपॉन आर नोट सी थी। ये कभी काम नहीं आएगी, क्या 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 होगी, बट ये एक्सप्रेशन काम आएगा कि एक लो पास फिल्टर के लिए कैसे लिखते हैं ओपन लूप ये रिस्पॉन्स, ठीक है, ये आपको याद रखना। हाई पास फिल्टर के लिए कैसे लिखते हैं वो भी मैं बता दूंगा कभी। लो पास फिल्टर के लिए इस तरह रिस्पॉन्स लिखते हैं। ये क्या होता है, ये ओपन लूप बोल दो या फिर इसको ऐसे बोलो कि जीरो फ्रिक्वेंसी पे जितना गेन है उतना, और ये ओमेगा एल क्या है, आपकी कट ऑफ फ्रिक्वेंसी है, ठीक है। फिर अपन ने इक्वेशन देखा, तो इसमें पहले ओपन लूप के लिए इन्फॉर्मेशन दी हुई थी, वहां से अपन ने क्लोज लूप के लिए इन्फॉर्मेशन निकाल ली। तो पहले अपना जो फ्रिक्वेंसी रिस्पॉन्स था वो इस तरह लग रहा था, लेकिन अब जब क्लोज लूप में चले गए, अपने ओपन लूप से क्लोज लूप में चले गए, तब फ्रिक्वेंसी रिस्पॉन्स इस तरह दिख रहा है। गेन इसका डिक्रीज हो गया है, बैंडविड्थ इसकी इंक्रीज हो गई है। तो 10 पहले 8 हर्ट्ज थी, अब ये 10 किलो हर्ट्ज तक चली गई है। तो अपन को 15 किलो हर्ट्ज पे गेन निकालने को कहा है। तो अब अपन को पता है ये लो पास फिल्टर की तरह, इस लो पास फिल्टर की तरह बिहेव कर रहा है। तो बेसिकली अपन ने इसका एक्सप्रेशन लिख दिया 80 अपॉन जीरो फ्रिक्वेंसी पे गेन अपॉन 1 प्लस जे एफ अपॉन एफ सी। तो अपना एफ था, अपन को 15 किलो पे निकालना था, और अपनी कट ऑफ फ्रिक्वेंसी थी 10। सो वहाँ से अपना गेन आ गया, जो क्या है 44.37। तो यही कॉन्सेप्ट होता है फ्रिक्वेंसी रिस्पॉन्स ऑफ ओप एम्प का। अब इससे रिलेटेड इक्वेशन आते हैं, कई बार पूछ लेते हैं कि यूनिटी गेन फ्रिक्वेंसी क्या है। तो उसमें आपको पता ही है गेन बैंडविड्थ प्रोडक्ट कांस्टेंट होता है, ठीक है। अब यूनिटी गेन है तो गेन की वैल्यू 1 दे दी। अब दूसरे वाले की फिर यूनिटी गेन फ्रिक्वेंसी फाइंड करनी है, तो उसको आप एफ टी लिख दो, यूनिटी गेन फ्रिक्वेंसी। तो पहले का जो गेन बैंडविड्थ प्रोडक्ट था वही आपका यूनिटी गेन फ्रिक्वेंसी होगा। तो ये सब क्वेश्चन पूछ लेते हैं। तो सब आपको ये बात ध्यान रखनी है कि ये वाला बहुत ज़्यादा यूज होगा, गेन बैंडविड्थ प्रोडक्ट कांस्टेंट है। उसके बाद आपको ये पता होना चाहिए किस तरह इसका एक्सप्रेशन लिखते हैं गेन का। तो वो लिखते हैं जीरो फ्रिक्वेंसी पे गेन अपॉन 1 प्लस जे अपॉन 1 प्लस जे इंटू एफ अपॉन एफ सी। सो यही कॉन्सेप्ट है, इससे ज़्यादा कुछ नहीं आएगा इसके अंदर। तो यही है फ्रीक्वेंसी रिस्पॉन्स ऑफ ओके, थैंक यू।